Hello, and welcome to the very first episode of Data Center Insights. Join us as we dive into the innovations and challenges shaping the future of data centers. From power management and cooling solutions to sustainability and regulatory updates, we'll cover it all. My aim is to bring you valuable insights that help you stay ahead in this fast-evolving industry. I'm your host, Emma, and I'm thrilled to kick off this series with a topic that's critical for anyone involved in data center management, operations, or design. So, let's jump right into our first topic today, the evolution of data center standards and what that means for the future of the industry. Over the last decade, data center standards have matured significantly, with extensive efforts at both European and global levels. Today, a comprehensive set of documents guides the construction, measurement, and operation of data centers. This progress marks a step toward operational excellence and sets the stage for the next phase of standardization. As these standards have been rolled out, they've gone through rounds of revisions based on valuable feedback from the industry. Both industry players and legislators have adopted this toolkit, sometimes using the tools in ways that weren't originally intended. Here's an example that highlights the practical challenges involved. The ASHRAE Thermal Guidelines introduce environmental classes A1 to A4 to help align data center cooling equipment settings with the design envelope of installed IT equipment. But here's the catch. If a server's maximum intake air temperature is set at 27 degrees Celsius, it doesn't mean you can simply set your cooling unit at 27 degrees Celsius and call it a day. The recirculation of air between the computer room air handler and the server could lead to a higher temperature at the server front end, say 29 degrees Celsius. While most servers can handle short bursts at these higher temperatures, prolonged exposure could risk both reliability and warranty conditions. To counter this challenge, one approach could be to increase the air pressure in the raised floor and cold aisle to prevent recirculation. However, this can undermine the energy savings you were initially aiming for, as the cooling unit fans would need to work harder and consume more energy. Even when outside temperatures are low and the cooling system is in a free cooling mode, setting the temperature at 27 degrees Celsius doesn't necessarily save energy. A more flexible approach, like using a dynamic set point, might be harder to implement but could offer better potential for savings. This example shows how rigid standards can sometimes lead to unintended consequences and why ongoing revisions are essential. On the topic of revisions, the ISO/IEC Working Group for Resource-Efficient Data Centers is currently revising the Power Usage Effectiveness, or PUE, standard that was introduced in 2016. These discussions have been lively, with many valuable proposals coming forward that reflect a commitment to continuous improvement in data center efficiency. In Europe, there's a significant focus on implementing the maturity model within the EN5 0600 standard series. This model is comprehensive, covering all aspects of a sustainable data center, and it could serve as the foundation for the EU Taxonomy model, replacing older references. This alignment is particularly important as the updated EU Energy Efficiency Directive is rolled out across different countries over the next year. The idea is to avoid redundant efforts and streamline the implementation of these standards across Europe. On the regulatory front, Germany has taken a pioneering step, being one of the first to implement stringent PUE values on a country level when it released its Energy Efficiency Act in September 2023, which not only mandates a maximum PUE of 1.2 for new builds starting July 1st, 2026, but also for existing infrastructures to decrease their PUE to 1.3 or lower by 2030. However, there's an interesting debate unfolding. The Amsterdam area, specifically the province of Noord-Holland, is advocating for an even stricter designed PUE of 1.16, a seemingly small difference, but in the world of PUE, it's a tough challenge. To clarify, the difference between a PUE of 1.2 and 1.16 is actually 0.085, not just 0.04. This nuance came up in discussions with a major engineering firm working on a German data center scheduled to come online in 2026. The difference might seem minor, but it has significant implications. If the German law had required a strict 1.20 PUE, the data center would have needed a complete redesign. But a PUE of 1.2 4999 falls within the acceptable margin of error for their initial design, saving them from a costly overhaul. As the PUE approaches 1, every incremental improvement becomes critical. A mere 1% increase in loss from the uninterruptible power supply UPS system can add an extra 0.01 to the overall PUE, which is why these small differences matter so much. As we anticipate the adoption of new European directives by other EU countries, including the UK, Norway, and Switzerland, collaboration becomes crucial. The goal is to formulate practical standards that address the diverse needs of stakeholders while shaping the future of data centers. Now, let's talk about some best practices for reducing PUE in data centers. First, power monitoring and measurement are key. You can't manage what you can't measure. Implementing intelligent rack PDUs for real-time monitoring and management can help track energy usage, identify inefficiencies, and make data-driven decisions for improvement. Intelligent PDUs, combined with a DCIM solution, can also help identify underutilized or zombie servers, allowing for significant energy savings. Optimizing cabinet airflow management is another crucial practice. Controlling bypass and recirculation airflows and limiting the mixture of hot and cold air are top priorities. This involves using blanking plates to fill gaps, sealing plates between the cabinet and the data center floor, and airtight cable entry seals. A comprehensive approach to airflow management can significantly improve energy efficiency and reduce costs. Introducing flexible containment is another strategy that can make a big difference. Ensuring the separation between hot and cold air by incorporating containment solutions, like roofs and doors at the ends of aisles, can result in significant energy savings. And when it comes to cooling systems, considering the latest rear door cooling solutions can help reduce cooling energy consumption by up to 90% with innovative air-assisted liquid cooling. This technology optimizes energy usage and increases versatility, which is especially important as data center demands continue to evolve. As we can see, the world of data center standards is evolving rapidly. New regulations, innovative cooling solutions, and more efficient power management practices are shaping the future. In our upcoming episodes, we'll continue exploring these developments, keeping you informed and ahead of the curve. Thank you for joining me on this first episode of Data Center Insights, sponsored by Legrand. Make sure to subscribe and share this podcast with your colleagues if you found it helpful. I'm Emma, and I'll be back with more insights and updates on the technology shaping our digital future. Until then, stay informed and keep your data centers efficient and sustainable.